Welcome to my class. I'm your teacher, Madam Kong. Today we are going to discuss pre-lab experiment for gas law. At the same time, I will brief about state of matter, gas as well. Are you ready? Let's start.
Some 4 basic assumptions for the kinetic molecular theory. Okay, volume negligible, intermolecular forces negligible. Okay, even though I just mentioned volume negligible, but when you explain, right, when you answer the question, right, you must mention volume of the gas particles is negligible. The intermolecular forces between the gas molecule are negligible. And then the average kinetic energy of the gas molecule is directly proportional to the absolute temperature of the gas. And then the collision between the gas particle are elastic. So jangan pergi jawab the collision elastic. Average kinetic energy directly proportional to gas. No, you must mention gas particles, gas molecules. Yeah. So based on here, right? Okay, we are going to learn this chapter. We have to know how to define Boyle's law, Charles' law, and Avogadro law. Based on these 3 laws, we form a ideal gas equation. At the same time, we need to sketch and interpret the graph of Boyle's and Charles' law. Okay, and then we need to perform the calculation involve gas law, ideal gas, gas law and ideal gas equation. At the same time, we will derive it by using density and molar mass. Okay, then we can calculate the molar mass of an ideal gas. Okay, of a volatile liquid using ideal gas equation. So we are calculating the volatile liquid. And then we need to know what is Dalton law. Okay, and then perform the calculation for Dalton law. Okay, there are 2 types of gas. One is ideal gas, another one is non-ideal gas. Non-ideal gas, the other name we call it real gas. Okay, yeah. Ideal and non-ideal behavior of gas, we need to know how to explain in terms of intermolecular forces and molecular volume. Okay, so first of all, right, we must know how to define Boyle's law, Charles' law, and Avogadro law. Okay, based on the slide I share with you, right? Okay, we go to here first. Boyle's law state that fixed amount of gas at constant temperature. So fixed amount of gas, constant temperature. So that's why fixed amount of gas, constant temperature. So this is the constant variable. There are 4 variables, pressure, volume, temperature, and number of mole or amount of gas. So we must know these 2 variables are constant for Boyle's law. And then what is the next? The next is volume is inversely proportional to gas pressure. Okay, volume is inversely proportional, meaning that when volume increase, pressure decrease. So now, okay, I can make some notes over here. Okay, you just jot down by yourself. Okay, you can use the symbol or use the wording also can. Okay, so meaning that when pressure increase, and then volume decrease, and then temperature and number of mole constant. That's why the equation is P1 V1 equal to P2 V2, because okay, based on here, right, okay, V is directly proportional to 1 over P. Okay, means V is inversely proportional to pressure. So PV will form a constant equal to K. That's why you will generate a formula P1 V1 equal to P2 V2. So this is mathematically expressed. And then you check for here. Okay, meaning that when pressure increase, so you press it, then the volume decrease. What happened? For sure, right? Okay, the collision between the molecule increase. Okay, if we check for Boyle's law, okay, this is the definition. One more time, when we define the definition for Boyle's law, we must mention the 4 variable. Okay, we must mention the 4 variable. So in this case, we will say, okay, at constant temperature and fixed amount of number of mole, the pressure is inversely proportional to the volume of gas. Okay, the gas volume is inversely proportional to the gas pressure. So check the graph. PV inversely proportional, but P over 1 over V directly proportional. If P1 V1, then over P, okay, is a straight line. So this is the K. PV is constant. That's why you will get the formula P1 V1 equal to P2 V2. This is Boyle's law. Next, how about Charles' law? Charles' law here, okay, for a fixed amount of gas, okay, means number of mole constant, constant pressure. Okay, constant pressure. So fixed amount of gas and constant pressure. So that's why I put equal. What happened? Okay, the gas volume is directly proportional to the temperature, mass in absolute temperature. That's why you must change to Kelvin. How to change to Kelvin? So by the temperature which in degrees Celsius, you plus 273.15. Okay, plus can be 273, can be 273.15. Both acceptable. Okay, so since okay V is directly proportional to T, right? Meaning that V over T equal to K. K is the proportionality constant. So we will form a formula for Charles' law, which is V1 over T1 equal to V2 over T2. Okay, so now try to fill in the blank. So in this case, when volume increase, okay, then the temperature increase. So volume of the gas particle or gas molecule is directly proportional to the absolute temperature. So you get the formula V1 over T1 equal to V2 over T2. Okay, so next, Charles' law. So this is the graph of Charles' law. V directly proportional to T. If absolute temperature, right, here we extrapolate to negative 273.15 degrees Celsius. If the x-axis is in degrees Celsius. If the x-axis is in Kelvin, okay, so it started from 0. If degrees Celsius is started from negative 273.15, you have to extrapolate the graph. Okay, now Avogadro law, constant pressure and temperature. The volume of gas is directly proportional to the number of mole of the gas present. So means V is directly proportional to N. V over N equal to the proportionality constant. So you get a formula V1 over N1 equal to V2 over N2. So try to check. Okay, constant pressure, constant temperature. So V increase and then number of mole increase. So that's why you get V1 and over N1 equal to V2 over N2. Okay, until now, get the idea about the Charles' law, Avogadro law, and Boyle's law?
Yes, ma'am.
Okay, so now we check. Okay, Boyle's law. Okay, Boyle's law is V directly proportional to 1 over P. So here, V is directly proportional to T. Here, this one, V is directly proportional to N. Because if you check, right, all related with volume. Okay, and then this one, inversely proportional to pressure, directly proportional to temperature, directly proportional to number of mole or amount of substance. So based on here, we can combine, okay, mathematically, if you combine these 3 law, right, okay, if you combine 3 law, okay, you sum up all the 3 law, so you will get V actually is directly proportional to NT over P. So from here, we can know PV is directly proportional to NT, and then we will form a constant, gas constant. So we will get PV equal to nRT. Okay, so PV equal to nRT. So the directly proportional now, we try to form a gas constant, which is R. Okay, and then there is a value for the R. The value of the R depends on the unit of pressure, volume, and temperature. So have to be extra careful. Okay, if you check the lecture notes, the R value, here is the R value. Because our equation involves pressure and volume. Okay, involve pressure and volume. So pressure, when the pressure is Pascal or Newton per meter, and the volume is in meter cube. So the R constant is 8.314 joule per mole per Kelvin. Okay, for sure, temperature must be absolute temperature. Means if degree Celsius is given, you need to pass 273.15. Okay, this is a mass. Okay, and then if the pressure given in atm, volume is dm3 or liter, so this is the R constant. Normally, right, okay, we will use this one. If the pressure given in Pascal or mercury or Newton per meter, right, so convert to atm. So how to convert? 101.325. You can check from the least constant. Least constant will give the R value. No worry, least constant will be given. These two values will be given. But you have to be careful. The question, pressure must in ATM. Okay, if not in ATM, right, try to convert to ATM. Okay, because one ATM 101.325 kilopascal is not significant, equal to 1 ATM. Okay, this one you have to check. Madam pun tak ingat I tahu 101, 325. So everybody please take out your list constant and have a look. List constant. I also have to check the list constant as well. Semua orang tengok tutorial. What is the list constant? Okay. Jangan terima je, kena tengok So open your book and check what is the least constant. Madam pun kena buka. Yeah. Okay, pressure. Yes. Now I will snap the picture for you all. You can check through Telegram. Okay, Bara, you will get yes. Okay. Check. So you check here. 1 ATM. 1 ATM equal to 760 mmHg. mmHg means millimeter mercury, or another unit is torr. Actually, it's the same thing. So you must, if given in torr or mmHg, you must know how to convert in ATM. Or 101.325 kilopascal, or 101.325 Newton per meter per meter. So if the pressure given in torr or mmHg or pascal or Newton per meter meter, Madam encourage you all change to ATM first. Okay, change to ATM first so that you can use the 0.080 something. Okay, will be given or not? Let me double check the right. Okay, yes, the gas constant will be given. Okay, the gas constant will be given. No worry. Okay. So now you know, based on Charles' law, Avogadro law, and Boyle's law, Charles' law, Avogadro law, it will get an ideal gas law. This ideal gas law is used to determine density, molar mass. Okay, we also can use to determine temperature, pressure of a gas. Okay, all of here, right, we are dealing with ideal gas. So the gas which obey all the gas equation means Charles' law, Boyle's law, Avogadro law. Okay, the P, pressure, V, volume R, the gas constant, and the temperature must be in the correct unit. Be careful, T must in absolute temperature. Okay, so for ideal gas equation, we can write, okay, like this, okay, so that you can get the idea, okay. The unit of R is gas form, pressure, RTM, volume in liter. And then mole is the unit for n number of mole, T is the absolute temperature. So when you calculate, right, this is how the R constant, how the value get from. Okay, because based on 22.4, okay, standard temperature and pressure. Okay, this is the absolute temperature. So this one is the unit for the R constant, liter ATM per Kelvin per mole. Liter ATM per Kelvin per mole. Okay, so this is what I explained just now. Okay, so try to this question, everybody. Try to calculate this question. First of all, mole, methane, volume, and then this one is temperature. Okay, so the question asks about what is the pressure? Pressure, I don't know. So this is volume, you have to change to something. Mass is given, you need to find out the mole. You must know what is methane, methane which is CH4. Is heated. Okay, temperature must change to Kelvin, so it's 27.115. Okay, so this is the clue. So if you apply PV equal to nRT, P equal to nRT over V. And then make sure V must in dm cube or liter. Okay, so you try and check. Yeah. So first of all, you must calculate the mole. Okay, the molar mass of methane 16 R. Okay, this is what I keep on emphasize, better in 0.08206. And then temperature 313. Okay, please don't ask me, whether 373 or 373.15 acceptable. Both acceptable. Okay, and then the volume that must change later. This is what I say. So you cancel, right? Mole, cancel per mole. And then per Kelvin, cancel Kelvin. Okay, so liter, cancel liter. So remaining unit is atm. So the answer is 96 atm. So you must understand how the PV equal to nRT derived from, and then apply the formula, write down the formula, apply the formula by substitution, and then get the final answer with correct unit. Make sure you clear the unit of each of the variable. Means volume must in meter cube, if using nano Newton per meter, or you all change to ATM first. Okay, change to ATM easier, so you can cancel all the unit. Okay, so this one. Okay, next. Just now we mentioned, right? Okay, we can calculate the density of molar mass based on the ideal gas. How? First of all, you should know, right? This is ideal gas. Okay, if you change to N over V, so N over V, here N over V, and then you change the RT over here, so no more V, so P over RT. So N over V, what is N over V? Okay, you have to double check. Okay, N over V actually, you must know N equal to mass over molar mass as well. N equal to mass over molar mass. So now you substitute mass over molar mass over V, and then you know that MV actually is the density. Okay, so this one molar mass you put to here. Okay, pressure times molar mass over RT actually equal to density. Okay, so again ada orang tak nampak. So asal dia PV equal to nRT. Ini satu. Okay, I tahu N sama dengan mass over molar mass. Ini dua. So sekarang I substitute 2 ke 1. Okay, so PV equal to mass RT over molar mass. Okay. Sampai sini boleh faham? Halo kelas. Boleh ya? Okay. So PV equal to nRT, N sama dengan mass over molar mass. 2 masuk ke 1, maka PV equal to mass RT over MR. Okay, now sekarang, okay, kita kena tahu, okay, sebenarnya mass over volume, okay, V ke situ. Okay, mass V ke situ, kemudian yang ini sama dengan P pressure molar mass over RT. Ini matematik Ini bukan kimia. Part sini bukan kimia. Part inilah matematik. So, sekarang kita tahu tiba-tiba terhasillah density. Mengapa? Kerana density sama dengan mass over volume. Still remember? Mass of solution over solution equal to density. So, now density equal to pressure molar mass over RT. Okay, jadi kat sini kita boleh kira density. Kita pun boleh kira molar mass. Yeah. So, this is how are we going to find the density of molar mass based on ideal gas law. Okay. Next. Okay, second part third part, suppose is third part. Part 1, Boyle's law, Charles law, Avogadro law. Second part, ideal gas law. Now is third part, Dalton's law. Bahagian yang ketiga, Dalton's law. The definition of Dalton's law is the total pressure of mixture of non-reacting gases. Walaupun dalam satu ruangan ada banyak gas, contohnya hydrogen gas, helium gas, carbon dioxide, apa jenis gas, but all of these right are non-reacting gases. Maksud dia stand alone, dia tak akan dia campur tapi tak chemical mix. So it's the sum of the partial pressure exerted, okay, means kena, okay, jumlah pressure yang kena by each of the gases in the mixture. Setiap memainkan peranan. So that's why P total actually is PA plus PB or PCPD tambah is the sum. Okay, so this one we consider as partial pressure. Okay, wow. Okay, this one considered as partial pressure of gas A, partial pressure of gas B, sum up together become partial pressure. This is the total pressure. Okay, what means by partial pressure? In a mixture of gas, right, each gas have partial pressure. Setiap jenis gas pun ada pressure dia. It's the hypothetical pressure. Secara teori lah of the gas if it alone occupy the volume of the mixture at the same temperature. Okay, tak penting jadi tahu je. So contohnya kat sini dalam ruang ini ada gas A, gas B. Jadi Dalton Law kata, okay, dalam ruang ini pressure A campur pressure B adalah sama dengan jumlah pressure. Okay ya. Just now we learned about PV equal to nRT. So of course if we want to know the PA, right, actually is equal to NART over V. Sama juga untuk PV, NB RT over V. Okay, now if you sum up, right, so the P total actually PA plus PB also equal to NART over V campur NBRT over V as well. Okay, if NT, of course, PT of course is NTRT over V lah. Okay, nampak banyak formula kan? So the Dalton Law actually will link with mole fraction as well. Still remember mole fraction that we learned in chapter 1? XA equal to NA over NT. Okay, this is a mole fraction. Mole fraction is the N of the compound A over the N total. So meaning that now PA we should know, okay, if the partial pressure of A equal to mole fraction of A times PT. So if this one we learned before, if we substitute, right, PA will equal to NA over NT PT. Okay, always remember, theoretically, suppose total is equal to M, but reality always smaller than M for the mole fraction. Okay, so if we check this question, right, question 5. Based on this example, right, $5.88. So this one considered is P total. Gas, methane, gas, helium. Hydrogen, gas, helium. So now the question asks about partial pressure of each of the gases. Okay, just I know this is P total. So meaning that I need to find the mole. I need to find the mole of CH4. I need to find the mole of hydrogen, the mole of helium. Okay, sum up these three gas, I will get the N total. Then only I will get the mole fraction. Once I get the mole fraction, yes, I can find the partial pressure. Once I get the mole fraction, I can find the partial pressure. Because just now we learned already here. Okay, once I know the mole fraction, I can find the partial pressure by using PA equal to XA times PT. Okay, this is what I say. Find the number of mole first. Find the mole for methane. Find the mole for hydrogen. Find the mole of helium. So I know the N total. Okay, here is the N total. Okay, so this is the PCH4. Okay, PCH4. So mole fraction equal to NCH4 over N total. So this one is the NCH4, and then N total you just sum up. So this one is P total times P total. So you get the answer. Don't forget unit. So for chapter 5, only part gas have calculation. Liquid, solid, and phase diagram there are no calculation. So hanya je phase bahagian gas susah sikit je kerana melibatkan kiraan. Okay, try to do the same thing. Okay, so to find the partial pressure of hydrogen, partial pressure of helium, which E, small E, then we get the answer. Okay, always remember applying the PA equal to XA over PT. And then the XA you can get from NA over NT. Okay. Oh, there is a second question. Second question asks about what? What is the partial pressure of CH4 and H2? if helium is removed. All the concept is the same, you just ignore helium. Now there are only two gases. So you just calculate as usual. Partial pressure of CH4 and H2 does not change if heat. Oh, does not change. Why does not change? Still the same, 1.5 and 3.9. You can remain 1.48, 3.92. Okay, why? Because according to the definition, right? Okay, the total pressure of mixture of non-reacting gases. All of the gas is non-reacting gases. So that's why the partial pressure is still the same, even though one of the gas is removed. Yeah, when one of the gas is removed, the partial pressure of each gas is still the same because they are non-reacting gases. Okay. Next, application of Dalton Law for the gas collected over water. This is one famous question. Famous question for Dalton Law. Okay. We must know, right, based on this question, what gas is involved. Normally will involve water. The water actually not water, but is gas. Okay, H2O gas means the state. Okay, and then oxygen gas. Yeah, always remember, for this kind of question, Dalton's law just involve gas. If solid or liquid are given, right, you just ignore. Don't be confused by the other information, which is not gas. So total pressure is not only for the particular gas, but also from the water vapor. Water vapor, as I said just now, H2O, steam, yeah, or gas. Water vapor, this is water vapor. So question 6, based on this equation. Okay, please be careful. When for this kind of question, first step, we must write an equation. When the equation is given, even though the equation is given, make sure the equation is balanced. Double check, is it balanced? Yes, balanced. Okay, next, you must identify the gas involved in this case. So in this case, a sample of 5.45 liter oxygen. So oxygen. So this is the volume. It's collected over water. So water here, okay, we need to know, right, actually it's involved the H2O vapor as well. This one is oxygen gas. Total pressure, so P total given in, this is what I say, TOR. So you must convert to ATM, must convert to ATM. Same for here, must change to Kelvin. So how many grams of oxygen have been collected? So step 1, equation. Step 2, identify the partial pressure. P total given equal to P oxygen plus P water. Over here, right, P water given as well, 23.8 torr. So what is the partial pressure of oxygen? So you will try to calculate first and then get 711.7 torr for oxygen, and then must change to ATM. Because just now, as we know, 1 ATM equal to 760 torr. Okay, now you change, okay, and then convert, you get the pressure, okay, in ATM. Volume, you get already, okay, because given 5.45 liter over here, is it? Yes, information, this is the volume. Okay, this is the total pressure. This one is the temperature. This one is the partial pressure of H2O. Okay, now since you get the number, the pressure already, you can know the volume already. Okay, ATM, right? So apply the R constant, which value is 0.08206. Okay, and then times 298 Kelvin, 25 plus 273, so you get 298. So this is the mole of oxygen. So once you know the mole of oxygen, right, the question asks about what is the gram of oxygen. So remember oxygen 3 atom must oxygen 3 atom, so mass times 32, 16 times 2. Okay, so you get the answer. So this is the concept about Dalton's law. After that, we need to know some theory about ideal gas and real gas. Okay, here are the theory about ideal gas and real gas, and then exercise about what we discussed before. Okay, there are 7. Okay, there are 8 exercises. There are 8 exercises related with Charles' law, Boyle's law, Avogadro law, ideal gas law, and Dalton gas law. Okay, and then question 1 and 2 answer. Question 2 answer is given. Question 1 no. First step, you need to understand how gases behave. is to look at what the atoms or molecule are doing. Once we see what is happening on a molecule level, we can use this idea to explain the properties of gases that we can actually see and measure. Let's start. Okay, try to use a thermometer. Okay, I will add hydrogen, 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 hydrogen. So this is the number of hydrogen. There are 5 helium. Okay, try different setting and list as many observations as you can about how the atom are behave. So first I try with one type of gas first. Okay, we check. Okay, when I decrease the temperature, what happened? When the temperature decreased, right, what happened? How about the kinetic energy of helium? Decrease, okay? Move slower. Okay, if I increase the temperature, you check. Okay, getting faster. Okay, try the maximum. Yes, faster. If you add more, right? Okay, you can see more clearly. What happened to decrease temperature? Increase temperature. Okay, now I try with, I add, okay, I remove a bit. Okay, I want to remain 5 only. 1, 2, 3, 4, 5. Now I try to add neon. Okay, what did you observe? How about the size of neon? Yeah, bigger, right? The size is bigger. Okay, and then we check the size of argon. Yeah, bigger. So, as we know just now, when temperature decrease, okay, the kinetic energy decrease as well. Okay, and then when the number of atom increase, right? Okay, more atom will move faster. So now I try to increase the temperature. Yes, the green particles, the pink particles, the orange particle all move faster. But orange particles move the fastest one. Move the fastest one. Why? You check. What is the difference between the green, pink, and orange particle?
The size.
Yes, the size. Okay, the size. Means that the size will affect the kinetic energy as well. Okay, the smaller the size, it will move faster when the temperature increase. So over here, there are a few factors. Amount of the particles, the size of the particles, and the temperature as well. Okay, next. Okay, this is simulation. The speed of the atom depends on the temperature. True or false?
True.
True.
Yes. Okay, good job. Different type of atom move at the same speed as long as they are at the same temperature.
False.
False. Not the same, just now. Okay, we noticed, right? Not the same.
False.
Very good. Okay, how about this one? Lighter atom move slower? No. Heavier atom move slower? Macam yes. There is no regular pattern between lighter and heavier atom. So which one is the answer?
Heavier atom move slower.
Okay, yeah, try. Yes, correct. Okay, in a sample of one type of atom, all of the atom will move at the same speed because they are at the same temperature. At the same speed?
False.
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 Okay. Yes. Okay. Just now we try. Okay. Good job. As you can see, right, the sample to the right, some of the atoms are moving slower and some are moving faster, even though they are the same particles. So that's why we take the kinetic average kinetic energy. That's why kita ambil purata, Okay. So based on just now, right, I did here. Okay, not here, not here. We check the definition, the assumption, the average kinetic energy of the gas molecule. Okay, this is the reason why we have to emphasize average. Okay, next. There will always be a mix of speed in any gas sample. That is why we always refer to the average speed of the atom. Okay, yeah. Next is about pressure. Pressure is defined by the following equation, which is force over area. This shows that pressure is the amount of force applied to a certain area. We can measure pressure in psi or pounds per square inch. A pressure of 5 psi means there are 5 pounds of force being applied to each square inch of the surface. Okay, kita tak fokus sangat kat sini ya. Okay. So the air molecule around us create pressure. Yes, this one, yes. In fact, the normal atmospheric pressure is around 15 psi. That means that there is about 15 pounds of force being applied to every square inch of your head and head and the rest of you by the air around you. Tapi kita tak rasa apa-apa kan? Okay, what actually caused this force? Let's check. Okay, watch the gas sample above for a minute. What is creating the force on the side of the container? That is being measured by the pressure gauge. Macam mana pronounce gauge ke gauge? Gauge. What pressure gauge? Nanti cuba Google search macam mana pronounce ah. Okay, kita try. Boleh try ke? Tak boleh buat apa kan? Next dulu. The force is caused by the impact of the atom with side. Okay, maksudnya dia, okay, mean the gas particle, right? Okay, will create the this how to create the pressure when the particles hit the container or hit among themselves. Wah. Berapa kosong? Okay, madam pun tak tahu. Think that the square inch of your hand each second the square inch get hit by the molecule in the air about times with an average speed about 1000 mph. All those collision create a 15 pounds of force on each square inch of your skin. Banyak lah. So what make the pressure change and why? So next we will look at the factors that can cause pressure to change. Yeah. So let's try. Okay, decrease temperature. Okay, when decrease temperature, the average kinetic energy of the gas particle getting slower, means decrease. When temperature increase, yeah, higher. So meaning that pressure and the pressure and the temperature is directly proportional. So pressure, temperature. So apply which law? Pressure, temperature. Pressure, temperature. Okay, there's no pressure and temperature, just normal. Okay, means not applying Boyle's law or Charles' law or Avogadro law. Where is it? Okay, next, continue. So use the thermometer. Okay. Oh, have to take 4 reading. 1, 2, 3, 4. Okay, next. A straight line, linear graph. The graph shows a direct relationship between the temperature and pressure. Next. Okay, P over T equal to constant. So a direct relationship means that the pressure divided by the temperature equals some constant number. Adjust the thermometer to see on both effect. Oh, okay. So P over T is equal to K. K is the constant. Okay, next. Why are pressure and temperature directly related? To answer this question, let's think about what the atoms are doing. Because as the temperature increase, the pressure increase. Because apa? There are more collision with the side, and each collision is more forceful because the atoms are moving faster. Yeah, more collision is happened. Okay, this one we will continue learn in chapter 1 SK025. We will mention about effective collision. Okay, for the time being, you just know there are more collision with the side when the temperature increase, and then each collision is more forceful because the atoms are moving faster. Okay, so now try. Okay, first. Okay, an increase in temperature, right? Cause?
Increase in speed.
Okay, then cause? An increase of collision force and collision frequency, that increase in pressure. Okay, next. Let's consider the number of atoms. Okay, so I add more. What happened? Use the button to adjust the number of atoms. Then take a reading. Okay, so I take the maximum first. Okay, then I reduce. Next. Okay, then I reduce. Next. Then I reduce. Next. Okay, so what happened? Again. Okay, the graph show another direct relationship, means directly proportional between pressure and number of atoms. Let's look at what this means. Okay, if you try to increase, okay, it will increase, decrease, decrease. Okay, as we saw, right, the pressure divided by the number of atoms, pressure divided by the number of atoms equal to a constant. So use the bottom adjust. So I done already. So next. So why are pressure and number of atoms is directly related? To answer this question, right? Let's think about what the number of gas atom doing. The decrease, increase. So as the number of atom increase, the pressure increase because there are more collision with the side, and the more collision, the higher the frequency. So meaning that now temperature and the number of atom will affect the pressure. is directly affect means the pressure will increase. When the temperature increase or when the number of atom or number of molecule increase, so pressure increase. Okay, so increase of number atom, so increase is number of collision, increase in pressure. Next, okay, now we talk about volume. Okay, volume. So this is the first reading, try second reading, third reading, or maximum already. So I try another one here. Okay, yes, here should be better. Okay, I took 5 reading lah, whatever. The last variable we will consider is volume. Change the volume of the container by dragging to the lower right corner. Yes, take pressure. So the graph show that indirectly relationship, inversely proportional between the pressure and volume. So the relationship between the pressure and volume is inversely proportional. Okay. So we can try adjust and then see what happened. Okay. When the size is molar, right? Okay, what happened? Greater. Okay, check the PSI value. Okay. When the volume increase, right, the PSI value is the lowest. See, getting increase. When the volume decrease, pressure increase. Yeah. So P times V is equal to constant indirectly relationship. So I can try to adjust here like this. In inversely proportional. Size smaller, pressure increase. If size means the volume larger, okay, the pressure decrease. So the answer, okay, okay, what doing? Okay, we try. As the volume decrease, the pressure increase because there are more collision with the side, and the more collision, the higher the pressure. Okay, so what happened? A decrease in volume will cause increase in the number of collision, increase in pressure. So now we have investigate 4 variables that are used to describe a gas: pressure, temperature, volume, and number of gas. This is what I mentioned just now: pressure, volume, temperature, and number of gas. Here, okay, here we have seen that these 4 variables are all related to each other. You cannot change one of them without changing at least one of the others. So at least 2. 2 must be constant, and then 2 will affect each other. So the key to understand how these variables are related is knowing how the atom in a gas behave. So now return to home page. Yes, we have done the tutorial. Now we go to the problem. Okay, let's do this together with madam. You must get 15 questions correct before you miss 3 to get credit for this question set. Okay, continue. Okay, everybody, please try again. I'll try one more time. When talking about the speed of atom in a gas, you must refer to the average speed because A, B, C, D. Semua orang sila jawab semula, kita buat sama-sama.
C.
C. An individual speed will change as it collides with other atoms. So we have to use an average. Yes.
C, madam.
Yeah, correct. Okay, next. Ini memang senang salah. Which of the following is the most realistic representation of the way atom in a gas? Okay, tak mungkin atas bawah je, tak mungkin kanan kiri je, dia mesti scattered around. So antara A dengan B je, you rasa yang mana? A dia pusing-pusing. Jadi
B.
Ini kan? Tandang. Yes, betul. Okay, which graph best represent the relationship between the number of atom and pressure? Number of pressure, okay, number of atom increase, pressure increase means directly proportional. Yes, A. Okay, next. Which graph best represent the relationship between temperature and pressure? Pun directly proportional.
A.
A. Okay. Okay, continue. Change the volume to create the highest possible pressure. Jadi kita kena volume kena paling kecil sekali lah. Kerana P is inversely proportional to volume. Okay, next. The image below is not accurate because mana mungkin pink lebih cepat, pink sepatutnya lebih lambat. Kerana pink tu berat.
A.
The heavier atom are moving faster than lighter one. Okay, tengok. Yeah, itu salah. Okay, which graph best represent the relation between volume and pressure? Inversely proportional.
C.
C. Okay, sekarang soalan ni pelik-pelik macam mana? Click the region of the graph that you would expect that the next data point to be found, the number of atom increase. Atom increase, pressure mesti increase kan? Jadi inilah, betul tak?
Betul.
Betul. Okay. So next, click the region of the graph that you would expect the next data point to be found if the temperature increase. Temperature increase maksudnya pressure pun increase lah. Betul kan? Betul ah? Betul ah? Betul. Okay. Which of the following sample you would expect to have the lowest pressure?
C.
C. Yes, lowest pressure dia bergerak sikit je. Dia tak ada pelanggaran yang banyak. Okay, which of the following sample would you expect to have lowest pressure? Okay, ni 4, ni 3, ni 2, ni 6. Lowest pressure means kena sikit lah. Bilangan zarah dia kena sikit. Jadi jawapan dia C. Am I right? Betul tak?
Betul.
Betul. Okay, next. Lagi 4 soalan. Okay, change the temperature to create a highest possible. Okay, highest lah. This is highest pressure. To naik. Okay. Change the temperature. Bukan dah jawab ke? Oh, lagi. Okay, dia ada 2. Change the temperature to create the highest possible pressure in the container. Jangan lupa container maksudnya volume. Kalau nak highest temperature, volume kena kecil. Temperature kena increase. Okay, yes. Okay, change the highest possible pressure in the container. Mengapa ulang je? Lagi apa? Lagi tambah sampai maximum. So meaning that number of particle, temperature, and the volume will affect the pressure. Okay, there are 3 factors. Okay, next. Okay, create a highest possible pressure in the container. Volume tak boleh tukar, pressure boleh tak? Pressure boleh. Boleh tambah? Ya, boleh tambah. Okay, dah submit. Continue. Yay, habis. Okay, return to home page. Tanya. Okay, so this is the reason why I want to discuss the simulation with you all one more time. Because very important for the concept that we discussed just now about about Charles' law, Boyle's law, and Avogadro law. So you must know how to sketch and interpret the graph of Boyle's law and Charles' law. And then we must know how to perform the calculation. Just now I show you a few examples already. And then next, which is not related with your tutorial, which is Dalton law. Okay, you must know how to define, and then it related with the mole fraction. Always remember Dalton law is PT equal to PA plus PB. Okay, and then you can calculate the PA, right? Okay, the PA by using XA times PT. And then the XA is get from NA over NT. So there are 3 formula involved for Dalton's law. This one you learn in chapter 1. Okay, this one you just learn PA equal to XA over times PT. Okay, so this part I haven't explained yet. So what is ideal gas? What is non-ideal gas? Non-ideal gas, there is another name we call it real gas. Okay, we have to explain in terms of intermolecular forces and molecular volume, and then we must know the condition for the real or ideal gas. Okay, so I will this explanation continue with this next lesson. Okay, so what I want you all to do, right? Okay, try the exercise over here. There are 8 exercise. Okay, exercise 2 is given already. The answer is given. Never mind, you try to do it by yourself again. So there are 8 questions. Please try this 8 question. Okay. By using test pack, you use your test pack, try this 8 calculation question. Okay, and then try to study about the condition for real gas, the condition for ideal gas, and then what is real gas, what is ideal gas by yourself first. Okay, that's all for today. Any question you want to ask? Okay, you can this one, before I forget, you can check your tutorial as well, the guided module. Okay, we no need to submit the guided module. You just go through by yourself and then study all the questions. Okay, there are how many questions related with gas? Question 1 until question 9. Okay, there are 9 questions related with gas. Okay, you study the question 1 until question 9 first. We are going to discuss next week as well. And then next week we will continue with liquid, solid, and phase diagram. Phase diagram is 5.2. Okay. So please do remember, must submit the exit ticket for this one. You just click exit ticket. How to get the exit ticket? So here, all the notes given, and then please click the Google form, and then sorry, done already this one. Click the Google form, and then the Google form will direct you to here. Okay, you just answer a few questions. Okay, next. Okay, let's try it together. Define Boyle's law. I think this one clearer. No. Okay, this define Boyle's law. Which one is the answer?
A.
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 Okay. Then this one, based on kinetic molecular theory, state how the pressure of gas change when the volume increase. Inversely proportional. Okay. And this one, state the variable for Charles held constant. Charles law, which one constant?
B.
Pressure and number of mole. Okay, so pressure and number of mole. Pressure and number of mole. B. Okay, this one. What is the volume of the gas at absolute temperature?
0.
Yeah, 0. Okay, and then this one you need to perform the calculation. We actually apply which law? Volume 2.5, 29 degrees Celsius. Okay, remember, change to absolute temperature. If the pressure is maintained constant, calculate the volume at 35 degrees Celsius. So meaning that this is related with temperature and volume. So temperature and volume. So temperature and volume meaning that you are applying Charles' law. Am I right?
Yes.
Okay, you try to apply Charles' law and you try to get the answer. Okay, then next. Okay, I random pick first. Okay, next. So entry ticket, the simulation, YouTube video I shared before. Okay, the teacher Wong one. And then Google Meet discussion. There are 2 Google Meet discussion for today. And then this is the quiz. And then the entry ticket tutorial, the 5 element. Okay, I joined. And then the exit ticket for the tutorial is Kahoot exercise. So you just give some review and then submit. Okay, that's all for today. Thank you, class.
Thank you, madam.
Thank
you,
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
Thank you.
Thanks for watching. Please do remember, subscribe my channel and follow my IG, TikTok, and Facebook. See you all again on next video. Bye.